Hi everyone, my name is Will Ross, product developer here at SkyCiv, and I'm back to share some updates on the foundation design module. One of the most requested features is the inclusion of hooks in the development plan calculation. And for the past months, we've been working on applying this update to all the design codes available in the module. So the main goal of this update is to have a more accurate and detailed calculation, especially since the development plan checks are often neglected by some. For this tutorial, I'll be discussing an isolated footing example following the Canadian standard. So first, let's go through with updates on the user interface and graphics. As you can see on the right portion of the screen, the default render contains 90-degree hooks on both longitudinal and transverse reinforcements. We also incorporated column dowel bars here. Meanwhile, on the left side of the screen where the inputs are located, improvements have been made on the reinforcement tab. Concrete cover was transferred from the miscellaneous tab, which now includes concrete cover for column, as you can see here. Additionally, options for the hooks has been added in the reinforcement configuration. You can see here by selecting your preferred ends, whether straight, 90 degree or 180 degrees, the render will automatically update. So let's retain the 90-degree hook. For columns, you may also choose whether to add or neglect dowel bars. It also now has the option to for the direction of the column bar ends, which is either away or towards the column. Moreover, in the miscellaneous tab, solver settings was added here. The punching shear edge factor was inserted in the settings along with some checkboxes for the development length calculations. So users have the option to whether or not calculate the development length for the dowel bars, the top bars, and the bottom bars. For this example, let's consider all of them. You might also wonder why some K factors or the development length factors have disappeared on this update. Well, this is because the module now auto-calculates it. This includes the bar location factor, concrete density factor, and bar size factor. So one might ask if this is true with other design codes. So the answer is yes. Before I run the design checks, let me just add some dead and live loads here. Let's add 100 kilonewton for dead load and let's say 5 kilonewton for the live load. Now let's check the results. We still have the table to have a quick glance if the design is passing in this update. So the utility ratio table is retained. So from that table, we then click the report button to check the calculations. So let's skip the first portion of this report and go over the development length since this is the main update. There. So here the tension development length for the flexural bars is the first in order. As you can see, the anchorage length guide was added for the available lengths notation. Here we have the available length for the left face moment, which is the left face of the column. We have the left and right side notation, which is LL and LR. We also have the right face moment, which is the right face of the column with the right and left side also. So modification factors from the auto calculation and input is also added here on the report. Then the required development length is calculated following section 12.5 of CSA 823.3-14 for hooks. And if in case of straight bars, section 12.2 was followed. So subsequently, available lengths for the left and right face moments are determined here. In case that the required development length will be greater than the available length, reduction on reinforcement area considered in the flexure checks will be reflected. As you can see here, both X and Z directions were considered in the calculations. In case of top bars present in the design, so similar order will be followed in the calculations. After the bottom bars, in case they're top bars, it will immediately go through that portion. In addition to the tension development length, we also have the verification of footing thickness, where it checks if the thickness is sufficient or not, considering the rebar detail, especially in the case of hooks as seen here. So we have this output table for that verification. Then finally, the column dowel bars development length are checked following section 12.3. It is then compared with the available length or available depth to get the utility ratio. Aside from the compression development length, we also check the tension development length for dowel bars. So in this portion, it is verified and calculated if tension is present. The format of each code may vary. So, however, much of the process I've shown for this example are synonymous for other standards. It is important to note that I used the Canadian standard for this example. You may try also ACI, Australian Standard, and Eurocode, depending on your location and requirement. You can also check out the combined footing with similar configurations and graphics as seen here. As you can see, the hooks are present for both top and bottom bars. And I'll not dwell on the combined footing since the update for the calculations are present for both. And I think that's pretty much it for this demo on the development plan update for this module. As usual, you can message the chat box for any inquiry. So thanks for watching and see you on our next videos.